Alright, so I'm just having the thought experiment happen, so I'm just going to jot down notes as I go. So you have a black hole, right? Event horizon there, though you might see it this way, because it's curving itself at the same time. So you have that, and it goes in all directions. That's a bit messy. I'll just go back a little bit. Anyway, all directions. So you have your black hole here, black hole. You have a line here all the way around. That's an orbital. That's an orbital. And these are electrons burning off. Or Hawking radiation. And they're actually at the same time compressing matter. It expels it expels matter to always burn off. Oops. Let's say burn material. Sorry, it's messy. Electrons burning off Hawking are as Hawking radiation, yeah. At the same time, compressing matter, it expels matter to always burn material until what is it? Dissolution? Dissolvency? Of the black hole. So we have this basic premise, right? So this is what you would call the is it accretion disk? And or maybe this is it. This is a better version because you'll see it. That's the light you're seeing burn. Okay. Yeah. So that's the I think it's spelled accretion. I might misspell it. Accretion disk. The light going off. Light ring. Let's just say light ring here. So we have that basic idea, right? So you have a black hole here with this gravitational ring that goes around here, goes all the way around. It's a compacting system, but that's what's black inside the thing inside here. And so what you're not actually seeing in here is the hottest material ever. So this is whatever this is, because as matter shrinks in volume, it expels more heat. It expels heat due to friction. If I can fit it barely there. All right, I'm going to move on to the next page. Due to friction. So just so you can see it a little bit better here. So you have an accretion disk here. These are electrons burning off, going all the way around. You have as Hawking radiation as we know it, or it was also called, I think it's either black energy or dark energy. I'm not quite sure. I haven't read that book in a while. All I remember is it was some form of energy. But I think it's called black radiation. Might be black radiation. I can't remember. It doesn't matter. For this experiment, it doesn't matter. We'll hold on to it later. So we have that. So let me just make a new layer real quick and explain what I've got on this one, just to make sure I have it explained. So electrons burning off, Hawking radiation, yep. At the same time, I hope it's easy to read. It's not easy to read. Same time, let's put a line here. Put a line there. Yeah. At the same time, compressing matter, it expels matter to always burn material until dissolvency. Oh man, it's a mess. Yeah, okay. Until dissolvency of the black hole. All right. So let's go inside. So, come on. Let's go. Oopsie. Go inside. So let's get on the next layer here. And I've made two by mistake. Oh well. so we have this. So we have this material here, right? In a sphere. So it looks like this or whatever. Doesn't matter. No, wrong one. There we go. Doesn't have to be perfect because it's constantly roiling inside. So it's going to be roiled in a way that it's becoming a substratus of lattices of materials down to a subspace material that we haven't yet defined. So it'll go molecules, atoms. I think it goes bosons, and then bosons, and then gluons. Is it gluon of boson? I'm blanking on that part. But then it breaks down into a gluon lattice where it would be crystalline in structure if we could see it as a crystal, but since we can't right now, I'm going to show you how to do that in a second because I've been working on that too. So anyway, so we have this layering. So it's like a core. It is a core basically. We're not in pen mode. There we go. So we have cores, right? Various cores. And then at some point we have the shape of the universe which cannot be moved. So whatever this is, that is a sub shape. But right now, yeah, I have a guess. This is just a guess in the dark. If gluons are 8 plus 1 types, all right, to make 4 dimensions. My bad. 4 dimensions to view to 1 dimension. So it goes 1, 2, 1, 2, 3, 4, to 1, 2, 3, 4, 5, 6, 7, 8, and then somehow there's a 9th. So, I mean, maybe it's like the same for, I mean, where's the extra gluon going, you know? Maybe that's just time here, so this is time and this is time? This one and this one, you know? Anyway, just a thought, so I'll leave that there. T dimensions. So then it would go, so this is 1 dimension, 3 dimensions, what is this? This is 8 dimensions. Yeah, and this is 1, 2, 3, 4. So I have just a weird feeling this might be true, but I have no way of proving it yet. So there's this and this and this and this and this, and then there's another time. That's also T, and that's also T. And that's not going to be legible. T. There we go. T. So then that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But these are doubled. So it would be 4. But then it would be a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 over 10. Well, plus 11. 4 over 11. Yeah. Have a higher chance of higher chance of probabilistic activation. Probabilistic activation. So using game theory, I think, is what we would use there. No, because it's win, lose, win, lose, win. You know, it is win, lose, win, lose. Because it's propagation of self to the continued state of self. All right. So anyway, so that's this one. Kind of just an idea. Dimensions. Yeah. 3, 8, and this would be 10, and this is 11. Let me make that a little bit clearer here. So that's 10, and this is 11, and that's the unknown. That's not even legible. Okay. So that's why you're trying to do string theory, huh? Anyway, so someone wanted me to build string theory into this session, but I don't know. I have to talk to someone about it. It's just it's probably nonsense right now, but it's just a thought experiment. So next page. Where were we? We were explaining black holes on the inside. Oh yeah, okay. We did the gemification of the universe, right? So we got that. Wait, what am I doing wrong? I'm in the wrong layer. All right, so we got that. So we'll say some end polygon. So we'll say some. Let me draw first. It'll take a second. I'll just draw a buckyball because it's easy. Not that easy. No, you need to do angle. Okay, sorry. Let me give some perspective real quick. There. Yeah, we'll just make it like this. That's wrong. So there's some gem classification of metamaterial here, you know? Doesn't quite matter what it is. We don't know it yet. So messy. Whatever. It doesn't have to be perfect. I'm being anal retentive. So we have this thing. Gemification of the universe. Gemification of universe. And those are lattices of final form before singularity. All right? So that means that this is everything compressed as hard as possible, as hard as able. In relativistically in spacetime. Relativistic in spacetime. So yeah, so this is basically the gem at the end of the universe, or at the center of every black hole. You know what I mean? Nothing too crazy. So there's that. Which means there's a lot of energy in them. Huh. Okay, so if we have a core, we can now construct the inside of a system a little bit better. If I can actually hit that button properly, maybe. Okay. No, am I in the wrong pane again? No. Okay, great. So we have our little core dude. He's just chilling, being the hottest thing in the universe right now. You can't help it. Doesn't really matter. Yeah. I mean, I'll connect these and these, I guess. And this and this and this and yeah. It's not too perfect. Yeah, I am very anal with this stuff sometimes. Let's see here. Let's cut that out. 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 And that's a bit wrong. Anyway. So we'll do this real quick. Sorry about that. So we have our core. It's some random. We'll call it copium. Okay, because that's hilarious. Black hole core. Core. Copium. I don't know. I think it's funny. Anyway, so it has this. So we have this system here, right? So we have. Let me just shrink it down so I know what I'm doing. Nope, wrong. There we go. Where's my button? There. Move it there. Edit. Transform. Scale. Oh, no, too much more than that. Yep. So we have a little tiny core. No. Now it's upside down. Great. Yeah, there we go. Yeah, that'll do. Yeah, there we go. Okay. So we have our core, which means that it's expressing a heat value. It's expressing in all directions. Well, I'll just say n direction. A heat value dependent on the lattice structure. Orientation. Oh, this has to come at a certain point. The core only occurs once the black hole is stabilized. That means there's an activation mode. Oh man, writing is so hard. Alright, yeah. Sorry, distracted. Shoot. Cut that out. Alright. Yeah, I can't put the music on while I'm recording a video. Too bad. It helps me think. Let's see here. So we have that. We have our copium core. Alright, okay, so that's core. There's always a core, so there's a core, blah, 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 blah. We'll just make it an M poly, it doesn't freaking matter. We don't know what the shape is. So, and then, but there's vectors. So there's vectors of force, heat, vibration. Ow. I'm sorry, I have muscular dystrophy. It's really hard for me to write like this. Heat. Sorry, force, vibration, and that's an R. Okay, and that's an R. Okay, cool. So it has its own uncertainty system, uncertainty principle. Has certain. See? No, that's not right. Principle. My hands are not working right now. Principle. Hertz at the 0 to 1 range at Planck. Yeah, so it's Hertz 1 over, I think it's Planck, minus Hertz 0 over, oh, it's probably over half a Planck actually. Yeah, so that goes up to here. So then it goes H1 minus H0 over, I want to say 1/2 Planck over 1/2 Planck. Okay. So we have that. That's a basic system for its vibrational construct in a volume, in one vector. So that's one vector. One vector. Direction. One vector. Yeah, that's the best I can say. That's all I understand it is. So we'll just say vector. Let me get it on a new page so I'm not making too much of a mess. Anyway, so we have vector. There we go, the wrong panel again. No, I'm not. Alright, cool. Vector. Uncertainty. There we go, misspelled it. Hertz 1 distance over 1/2 Planck. Minus Hertz 0 distance for 1/2 Planck. Alright, so that's copium core vector. And then we'll see black hole. Alright. So we have that. That's easy enough to understand. So we have this. So that means that it has a shell. We have a core, and then we have a shell of instability in 4 dimensions. So 1.24 per moment per interaction per moment times number of interactions possible. Okay, interactions possible minus actual loss Let me fix that for you real quick while I can, because I'm about to lose my focus for the minute. And I'll come back to this because this is kind of fun. So anyway, so we have this thing. So it's got the end dimensions here. So we got red, green, blue, and then down here we have time. All right, and they all connect. And these are gluons. And then from there we have our crazy 9 tiles. Oh, I see why. Oh, because that's the shape. Because each of these have 2, and each of these have 2. So it is 9. Incredible. Okay, cool. Anyway, these don't connect, but they do connect to each other. Not pretty, but we're getting there. Let's see, we got red, 2, blue, 2, and green, 2. Yeah, okay. So that's basically the shape of a gluon, and this is the shape of a photon, I would assume. So we have photons here. Which is really close to what I did mathematically. So yeah, it's very similar. This is probably straighter. And this is probably straighter, and this is probably nicer looking. So it's probably more like kind of thing, you know? Kind of pretty. But anyway. Getting beyond myself here. I am waning. My attention span is waning. Let me post this online, and we'll talk about this more. So if... let me make a new layer. Nope, we've done that one already. If you are curious, please ask questions. Sorry about that, my writing sucks. Questions on science. Part 2 soon. Okay. Alright, and then one more. Thank you for watching. There we go. That's enough for now.